Hi, you can hear me? Yeah, good. So I'm going to talk about web performance considerations in a mobile world. So I'm assuming that most people know about web performance optimization, and I'm going to focus on the mobile world. And this is a 90-minute talk put into 20 minutes, so I'm only going to touch on the points that I think that you don't know. What you do know is that mobile browsers are awesome. They're the funnest thing to program in because you can pretty much do anything that you want to do, and you don't have to worry about IE6, IE7, IE8, IE9, IE10. No, IE10 is actually a good browser. But the thing is, we do have crappy devices and crappy browsers still coming out. Android 2.3 is still being sold today, and it's 30% of the Android market. So if you think about what you are using, this has 16 gigs of RAM. In terms of the phones in this room, you probably have an average of about 1 gig of RAM and a 1.7 hertz processor. But that's not what's happening in the real world. In the real world, people have on average, a quarter to 1 gig of RAM and much lower CPU. And 30% of Android is, and it's still being sold, is 2.3, which has no power or capabilities whatsoever. So when you're thinking about the mobile world, you have to consider what your users are not considering, and you have to think about the crappy devices. You have to think about the IE6s of the mobile world. You have to think about battery. You have to think about latency, memory, and responsiveness, in addition to everything that you've been thinking about. So the analogy that I like to give is the car battery versus the flashlight. When you're, like right now, I'm only up here for 20 minutes and I'm plugged in, right? But my phone, I plugged it in 2 days ago and I don't plan on plugging it in before I get back home. And I'm thinking this will last because I'm not using any applications while I'm here because I have to pay $20 a meg for roaming. Oops. But so when you are plugged in, you're kind of like the car battery. You're not really thinking about your battery. You know it's going to run out, but you know that you're going to have power soon. Your users aren't thinking about their battery. They know if they're using GPS or playing Angry Birds that their battery is dying. But if they're visiting Wikipedia, they're not thinking about the battery power that they're using. That's your job. So just like the flashlight, you turn it on when you go into a room, and you turn it off when you leave the room. As a web developer, you have to think, let's use their battery power when we load the application, and let's not drain their battery in between. So in terms of JavaScript, what drains the battery? We all know that when you load a page, you're rendering the JavaScript, you are rendering all your images, and that is using battery power. And that's when you should stop. What's happening is the biggest drain of battery is actually waking up the radio. And so when you're making AJAX requests every 10 seconds, you're waking up the radio and you're draining the battery. So if you can possibly prefetch, definitely prefetch. So these are a few tips. Actually, these are the few tips. I'm not going to go over the previous slide, except for the one thing on the previous slide. I'll go over it, which is don't include a library if you don't need to. That's including a lot of JavaScript and a lot of overhead that you might not need. So if you just need to get an element by tag name, or rather by class name, or if you want to basically query on selectors, don't include jQuery. Just do a document query selector all. It's supported everywhere except for Android 2.2 and lower. Basically, think about using a framework before you actually implement it because it is going to drain the battery. So a few tips. Avoid reflows and repaints, and I'm going to talk about that in a little bit. Minimize your JavaScript, both in size and activity. And like I said, don't include a framework if you don't need it. Basically, only load resources that you need. But in terms of only load resources that you need, prefetch if you can, so that you're not draining the battery by turning the radio back on to get a new part of the site. If you're going to animate, I recommend not using JavaScript for animation, and we're all JavaScript developers here, but CSS does awesome animation, and your browser is optimized for CSS animation. If you are going to animate, don't use set interval or set timeout, if at all possible. Use request animation frame. because your browser, most browsers are 60 hertz per second, 60 hertz. Not all are. That's 16.67 frames per second. If you're doing a set interval or a set timeout at 16.67, that is putting the request onto the into the stack, and it's going to be called not necessarily at exactly 16.6 seconds, 67 seconds, which will create jank. So it was much easier for me to do a circle with a red line through it in CSS than it was to do the warning sign. So all my red slashes are just warnings. They're not like, don't do it, but think about it before you do it. One of the things that drains the battery the most are ads. And why ads? Because they're refreshing every few seconds, or every 30 seconds. So they're waking up the radio and therefore draining the battery. And then third-party scripts. This is the Huffington Post, and this is the third-party scripts that the site loaded up for me. There's 26 third-party scripts. So be in control of your third-party scripts, because you don't want it to be a single point of failure, but you also don't want to be downloading that many scripts, because every HTTP request, well, let's talk about latency. So when you are developing for desktop, latency is an issue, but it's really a minor issue because you're connected on Wi-Fi. When you're on a cellular network, you might have metered bandwidth, like I do when I'm traveling to Europe. So that's why my phone is off. It's on airplane mode. But also it takes much longer to make a request. So usually, when you're on a desktop and you're making a request, you're on Wi-Fi, it's going from the computer to the router to the server directly, making the DNS request, coming back, and then you can get the site. When you are on a cellular network, it's going to the cell tower, to the phone company, to a DNS server, back through the phone company, back through the cell tower, back to your phone, back to the cell tower, back to the phone company, to the server that has your site. Most of the latency occurs right here between 1 and 2, which is in the air. And that slows things down a lot. So the more number of DNS lookups that you have and the more HTTP requests, the slower your site is going to be. So you want to reduce the requests as much as possible. So you don't want to have 26 requests for external JavaScripts. That is crazy. So you want to reduce the DNS lookups. You want to reduce the file count. And you also want to reduce the file sizes as much as possible. So when it comes to websites, images are the biggest culprit, not JavaScript. Images are actually the largest culprit. So you want to not just reduce the external scripts that we were talking about, but you want to reduce the size of your assets. So that's where responsive images comes in. And right now, there's 3 ideas that are on the table, but picture seems to, it's not, that picture element is not going to be the solution. So the picture element was basically like video or audio where you had the picture or element and then you had different sources. That is probably not what's going to be implemented. But the reason I'm still mentioning it is because picture fill, which kind of replicates what the picture element was supposed to do, works really, really well. The 2 drawbacks for picture fill are that it requires JavaScript to get the image, and number 2 is because it requires JavaScript, it's not loading the image until your site has loaded and your JavaScript is parsed. What is probably going to be implemented is source set. It's actually in the nightly builds for WebKit right now. And the way that works is you just use the regular image tag, either IMG or actually you can use IMAGE because that was supported. It's IMAGE is supported in all browsers, but don't use it just because it is. And then you add the source set attribute. So the default, every old browser will download source unless they understand source set. And then they'll say, okay, if the max width is 640 device pixels, or rather CSS pixels, then download small JPEG. If it's 640 wide with 2 times the DPI, download small, high DPI. And if it's twice as big, but regular resolution, twice the resolution, but any size larger than 640, download large HD. And the reason that large.jpg is not there is because that would have been in the source in the first place. So this is kind of a complex way of writing it, but right now this is the syntax. What we are also likely going to get is client hints. Some people think of client hints kind of like a UA, user agent string, but I don't think we're going to have the problems with spoofing or with lying on client hints. So what client hints is it's an HTTP request that returns the device width, the device height, and the pixel ratio. So you can actually do your image serving server side. You can say, okay, if it's this, send that out. And yes, a user agent could lie. The HTTP request could lie, but that might be because someone is choosing to lie because they want smaller images because they have limited bandwidth. While we are waiting for these to take effect, I came up with this solution called the clown car technique. Oops. Going all over my slide deck. So what the cloud car technique is, let me just show you it in action. So this is the default size. If I do 10%, you'll notice that the image changed. And if I do 100%, I have yet a third image coming through. Oops, there goes my slide deck again. I don't know how to use Keynote, so I use HTML5, and I forgot to, when I'm in something, to stop it from going from left to right. So how does this work? Can you guys see this okay, or should I? It's okay? So let me actually, even if it is okay, I'm going to go into a bigger file. So what it is doing is using the object tag and pulling in an SVG file. And the SVG file itself is pulling in the correct image. So the trick to it is in this right here. I have a view box with the size of the default image, which is 300 by 329, starting in the top left-hand corner. And I'm preserving the aspect ratio. And then I'm basically saying media screen, if it's between 401 and 700, then send a medium image. You know, I have a big image, a huge image, and a small image. And the code itself is right here. It basically says object data, and there's a data URI, and what it did is it concatenated that whole SVG, it minified it, and escaped the characters. So you have to escape the characters for IE10, and this works everywhere except for Android 2.3 and lower. So it even works in IE, because in IE you can use the, if IE less than IE8 doesn't understand SVG, you send the default image. So this actually is a solution until one of these other ones works. The reason that I use mine instead of picture, because picture works very, very nicely, is because picture requires JavaScript. My clown car technique does not. So we're all JavaScripters here, and you might want to use a picture element or picture fill instead, but realize that if you're using JavaScript, always do progressive enhancement. So clown car technique will work before your JavaScript is parsed. Okay, so what does all of these techniques do? They optimize for speed, they reduce the bandwidth, and also because you're serving the correct image for the size of your device, you're reducing the memory because you're only sending, a smaller image to a smaller device. Okay, so I also want to cover responsiveness, and there's two types of responsiveness that I want to cover. One is the user interaction, and the other one is re-rendering time. So let me just talk about responsiveness first. If something is less than 100 milliseconds, it seems instant to the user. The problem when you have a mobile device is it's waiting for that second click or second touch to see if you're going to pinch and zoom. So there's a 300 to 500 millisecond delay before the click event happens. So all mobile devices understand click events. Even though they understand touch events as well, they understand click events because every website until 3 years ago was only using click events, was not using touch events. But the devices are waiting 300 to 500 milliseconds before throwing that event. So what you want to do is you actually want to hijack the click event with a touch end. And the only problem with using an add event listener for touch end is when you're scrolling up and down the page, you're touching the page. So the touch end will be thrown when you're done scrolling. If you're on an element and you're scrolling through it and has an event, it'll throw that. One way to get around the 300 millisecond delay is to put the meta viewport and not enable scrolling. And I believe this works in Firefox, Chrome, and WebKit. I'm not 100% sure. But the problem with this is you're reducing accessibility and usability because you're preventing zoom. And I don't know about you guys, but I wear grandma glasses when I'm reading, so I'm always zooming on huge. So don't disable unless it's actually a game where you're never going to allow them to zoom. Don't just disable zoom because you don't want to code. So when you're doing mobile, because of this 300 millisecond delay, try doing touch end, but also always provide user feedback that an element has been touched and that you are going to be updating the site. Fetch the data, but provide them with feedback that that you understood that they touched your page, and then update the page when ready. But definitely provide feedback. Second part of responsiveness that I want to cover is jank. So devices, you want to hit 60 frames per second, which is 16.67 milliseconds. So request animation frame will, if you're going to do animation with JavaScript, definitely use request animation frame because it will optimize it for you instead of set interval. I talked about that. But what people don't realize is that 16.67 seconds, what the browser needs to do during that time is they need to edit the DOM, if you're using JavaScript, calculate the styles, do a layout, and then paint. And so we've never really been thinking about paint as an issue because painting is really fast, and when you load the page, if something takes 16 to 20 milliseconds to paint, who cares, right? But if you're animating something, that's a major deal. So in terms of reflows, these will all, and you guys already know this, so I'm not going to cover it. But what I really want to talk about is long paints. So there's a few CSS features that will take a long time to paint. One of them is huge radial gradients. And so this crashed my browser when I was working and freelancing at Apple many years ago, but I just thought I'd make a nice little curve with a gradient. And what happened is this is actually what was being drawn. When you drew a radial gradient, it draws the whole gradient to memory. So if you're animating something like this, especially if it has transparency, it's repainting that and figuring out exactly what each pixel needs to be every 16 milliseconds. So I just added this to prove that I am not a graphic designer. But the point of this was actually to show you there's only 2 divs being repainted. So the DOM is minimal on that screen. And just to do that hideous repaint takes 18 milliseconds just to repaint every frame. Just to repaint 378 by 720. So realize that painting is a major issue because right now it's bringing us there it is. So this is when the image is small, when the image is big, I'm going over those with 2 DOM nodes that I'm painting. Okay. So what you want to do is you want to hardware accelerate. You don't want to hardware accelerate everything. 2 ways to hardware accelerate is to use either transform. You sometimes, on some devices, you still have to use translate Z to put it into 3D space, but you're creating a new layer. So opacity and transforms generally create new layers, but just throw in the translate Z still until all browsers support it on basic transform. Painting, it'll just paint if you have to do an outline or a shadow. And that's what, on those 2 things that you saw, I was basically doing an outline and a shadow. When you're doing a background image and you're resizing it, when you're doing that on page load, that's easy. It's really cheap to parse and display an image, but it's really expensive in terms of that 16 millisecond window that you have to actually animate a background image. And then when you're doing layout with animation, changing layout with height, width, or border, you're basically going to be laying out everything on the page after it. So be careful of those. Just to finish up, realize, I already said this, that the memory is limited on these devices. T-Mobile, the cheapest Android device that they're selling right now, on the prepaid phone, runs Android 2.3 with 256 megs, and that's what they're selling today. And when you have a device, this is not this phone, this is the phone I had before, but I had 768 megs, but I had either 73 or 255 available, because when I bought the phone, all these native applications were running. So realize that the memory you think you have, you're actually limited below that. So in terms of those repaints, there were only 2 DOM nodes being repainted. Minimize your DOM, because every time you do an animation, it's, if you're changing layout, it's repainting every single node. Relaying out every single node. So the fewer DOM nodes you have, the faster it is going to be to animate, and the faster it is going to be to calculate everything. So what you want to do is you want to, and it's going to use less memory. So you want to batch your DOM nodes. So as an example, here's a game of Tetris. The score that this person got was 3 million. Can you imagine if every DOM node was just tossed away and waiting for garbage collection? Instead, you can just do 12 by 30 or whatever the size of this thing is, and you can use just that many DOM nodes and reallocate them instead of destroying them. Reuse instead of allocate and destroy. So those are just a few tips. I had to figure out which ones were the most important and which ones you might not, might be newer to you. But if you have any questions about any of this, or especially CSS, what works slowly on the device, I'm going to be here the whole conference, so feel free to ask me questions after that. And if you want to stay in contact, that's me. Thank you.